So now that we've talked a bit about concepts for sequential programming, let's talk about the pros and cons of doing things this way. And as always in computer science, there's pros and cons. And part of your responsibility as potential computer science professionals is to learn to evaluate the pros and cons of things. So let's talk about some pros and cons. In particular, notice that the cons we're about to talk about motivates the rest of the course. So we're going to do this just for like another lesson, and then we'll go on to the fun stuff related to concurrent and parallel programming. So what are some good things about sequential programming? Well, the most obvious one is it's easier to program and debug compared with or relative to concurrent and parallel programs. Your programs still could be hard, but they will be most likely be easier to program and debug than concurrent and parallel programs. And why is that? Well, they're typically more intuitive, since the steps that you see in the code are going to match what actually happens. Very much like what we were just talking about things not being reordered in mysterious ways. So here's an example of selection sort, which is an algorithm you probably learned about in either the data structures and or the algorithms class. And you can understand this, to the extent you want to understand it, by reading it sort of top to bottom. There's no surprises lurking here. Things aren't happening out of order and stuff like that. In fact, I would argue that selection sort is probably the easiest sorting algorithm to understand. It's really easy to understand, and it's pretty easy to understand it even when it's written in somewhat uncommented gobbledygook code like we see here. That was mostly done just to fit on the slide. Another thing that makes sequential programming nice is that the behavior in the debugger actually reflects what your program does, which is a huge win. You don't end up with so-called Heisenbugs. Conversely, non-sequential programs, concurrent and parallel programs, often differ when you run them in the debugger versus when you run them in the wild, in the production system, which of course is really frustrating because everything works great when you're debugging, and then you go and you deploy your system and it crashes and weird results happen, and it's like, what is going on here? You can read this link for more information about sort of why that happens and what to do about it. Why does this occur is because there's often perturbations in timing from running in different execution contexts. When you run in a debugger, it runs at a different speed. You may put breakpoints in certain places, so it's not going to behave exactly the same way it will do when you run it in production code. Very, very frustrating, by the way. Deterministic execution order simplifies reasoning about and assuring program behavior. Determinism is often a good thing from the point of view of quality assurance, testing, debugging, and so on. Maybe if you've ever seen the movie Clockwork Orange, deterministic behavior is not always desirable for other reasons. If you want to shock yourself, you should watch the Ludovico technique applied there. And nowhere is this more true than in safety-critical cyber-physical systems where the right answer delivered too late becomes the wrong answer. And here's a good example, which I've seen before. Self-driving cars, which are nice at one level, can get overwhelmed by sensor input, and if they're not programmed correctly, things go awry, you have accidents, bad things happen. Of course, usually, it used to be when you had an accident, it was the driver's fault, and now when you have an accident, it's the software's fault or the hardware's fault. So it changes the focus on who's to blame, who's liable. Of course, not everything is unicorns and rainbows, as we'll talk about repeatedly, so there are cons of sequential programming as well. So one of the most obvious ones is there's no easy way, or really no way, to leverage the inherent parallelism that's available in today's multi-core systems, where you've got lots and lots of cores and all kinds of clever optimization techniques that take advantage of out-of-order execution and loads and stores that can pass each other in the memory hierarchy and so on and so forth. Sequential programming just can't take advantage of that. And as a consequence, the performance of sequential code suffers relative to well-written concurrent and parallel programs. So a well-written concurrent and parallel program in a context where parallelism makes sense, because parallelism doesn't make sense in every context, well-written programs can leverage multi-core processors much more effectively. And here's an example of just some notional workload where you can see the sequential code really doesn't speed up a whole heck of a lot at all, as you would expect, whereas concurrent and parallel code can speed up. We will talk next time about the difference between parallel and concurrent code. Another issue with sequential programming is its responsiveness often suffers when you're confronted with many input-output sources and sinks. These would include things like mouse movements, mouse clicks, touch events, GPS signal locations, location signals, network connections, asynchronous, read and write operations, et cetera, et cetera, et cetera. And if you only have one thread of control, you either make things really, really non-responsive or really, really complicated to program. And if you remember the bad old days when we had a lot of that kind of code, you would see the hourglass, which was an Apple thing, the hourglass, and then you have spinning wheels, and those are just examples of what you see when stuff is not able to keep up with the load with a single thread. So having only one thread of control complicates the structure of sequential programs when operations may need to block. What a pain. So one of the things we're going to see when we start talking in more earnest about concurrent and parallel programs is blocking operations become way, way, way easier. Now, there are other ways out of this, typically by using asynchronous processing, and we'll talk about some of that too, but you're kind of robbing Peter to pay Paul if you're not careful, because the patterns of asynchronous programming are quite different from the patterns of sequential programming. That's a whole other topic for a later part of this course and my other course that I'll teach in the spring. So, overcoming these problems, motivate all the stuff we're about to cover. So this is really the end of the sequential stuff. I just wanted you to know what the baseline was. This is hopefully things that are just review, but maybe looking at these concepts a bit more systematically. And when we talk next, you'll see that all the assumptions that we made about sequential programs suddenly disappear and change when we deal with parallel programs. So that's the end of the discussion about the pros and cons of sequential programming.